Alright, so in today's classwork, the directions say factor completely or state that the polynomial is prime. So on almost all of these problems, there is some type of GCF that starts the problem. So we always want to see if the problem that we're factoring has a GCF. That's the first way of factoring that we want to try to start our problem off. So in this problem, we do have a GCF between the two terms, and that GCF is going to be 5x. When we factor out of 5x, we are left with x squared minus 9. And our directions are giving us a hint here. They're saying factor completely. So in this problem, once you factor out the 5x, it probably means you have something else that will factor again. And that something else is our binomial, x squared minus 9, and we call that the difference of two perfect squares. So we bring down our GCF. It's still a factor. We bring it down, and then we factor x squared minus 9 into x plus 3 times x minus 3. And we take a look at each factor. 5x is factored completely, x plus 3 is factored completely, and so is x minus 3. So this would be our answer with the problem factored completely as far as it will go. In example 68, we have a trinomial, but we do notice there is a GCF among all three terms, and you're always going to want to factor that out first. Between 6, 18, and 60, 6 would be your GCF. All terms do not have an x, so I cannot include an x in my GCF. So I'm going to factor out 6, and I get x squared minus 3x minus 10. Again, I'm asked to factor completely. 6 is factored completely, but x squared minus 3x minus 10 is not. So I bring down that 6. I have a trinomial to factor. It's going to factor into two binomials. To get the negative 10, my signs have to be different. The only way to get x squared is to do x times x. This is going to be an easier trinomial because the understood coefficient of your x squared is a 1. So I'm going to be looking for two things that multiply to be 10. And remember, since it's a negative 10, my signs are going to be different here. That multiply to be 10 and combine to be 3. So if my signs are different, I'm going to be subtracting 1 and 10 or subtracting 2 and 5. So 2 and 5 do subtract to be 3. You're going to need your 5 to be negative, and you're going to need your 2 to be positive. So when I place the 2 in, I want it to be positive. When I place the 5 in, I'll place it where the minus is. Let's check to see if we've factored completely. 6 is factored completely, x plus 2 is factored completely, and so is x minus 5. So that's my final answer. Number 70, again, always check for a GCF. So there is a GCF between these two terms. It is a 7. When I factor out a 7, I get x to the 4th minus 1. You have to have that minus 1 or your two factors do not multiply correctly. And then we have to see if anything else will factor. 7 will not factor again, so I'm going to bring it down. But x to the 4th minus 1 is the difference of two perfect squares. It's one of those binomials that we know how to factor. So we're going to factor into two binomials. We're going to need an x squared times an x squared. We're going to need a positive 1 times a negative 1. And again, we're going to look at our factors. 7 cannot be factored again. X squared plus 1 is the sum of squares, and that is not factorable. But then we get to x squared minus 1, which is the difference of squares, and we know how to factor that. So we bring down the 7, we bring down the x squared plus 1, and then we factor x squared minus 1 into two binomials. We have an x times an x, and then we have a plus 1 times a minus 1. Then check all of our factors. 7 can't be factored again, x squared plus 1 cannot be factored again, x plus 1 cannot be factored again, and x minus 1 cannot be factored again. So these are my final factors. Number 78 is here to kind of confuse you, to trick you. X squared plus 36, you would check for a GCF. There's not a GCF. And you would say, well, this is a binomial. Okay? Maybe a lot of you think that this could be factored. But this is the sum of squares. The sum of two perfect squares is not on your list of something that we can factor. So this is not factorable in any way. And when your problem cannot be factored, it's considered prime. So we would answer prime here. There are no two factors that multiply together to give you x squared plus 36, so our answer is prime. Number 80. We have 4 terms. When we have 4 terms, our clue is grouping. We'll group the first 2 and the last 2 terms. We did several of these today in class. The GCF between the first 2 terms is x squared. When we factor out an x squared, we're left with x plus 2. That means we want our next group to be exactly the same thing. So that's going to be x plus 2, and we have to ask ourselves, what can we factor out of negative x minus 2 that will give us positive x plus 2? And the answer to that is a negative 1. Okay, a negative 1 factored out of negative x minus 2 is going to give us positive x plus 2. Now my groups are the same, so I can actually factor out my group. So I can factor out x plus 2. That's going to cancel those out, and you'll be left with x squared minus 1. Take a look at our factors to see if we can factor them again. X plus 2, we cannot factor that again. We'll bring it down. X squared minus 1 is factorable. It's the difference of 2 perfect squares. So it's going to factor into 2 binomials. You'll have a x times a x, and you'll have a plus 1 times a minus 1. Take a look at all your factors. None of them can be factored again, so we have factored the problem as far as it will go. Alright, these last few examples are kind of difficult because the exponents are fractions, but we're still going to go with the same concept. This will be a little bit harder because we're dealing with exponents that are fractions. So we're going to ask ourselves, is there a GCF? Well, there's an x in both of my terms, so yes, there's a GCF. So I can factor out an x, and I'm going to look at the 2 exponents to decide which exponent is the smallest. So between 3/4 and 1/4, the smallest exponent is 1/4. So my GCF is x to the 1/4. Again, x is in both terms, and 1/4 is the smallest exponent. So my GCF is x to the 1/4. So I'm going to factor that out. Factoring is dividing. These are a little bit harder to divide, so you might want to go over to the side, and you might want to write this down. So we're going to do x to the 3/4 divided by x to the 1/4. We're going to use our quotient rule for exponents, and we're going to subtract our exponents. So we're going to bring the 1/4 up, and we're going to subtract. That's going to leave us with x to the 2/4, which reduces to x to the 1/2. So when you divide x to the 3/4 by x to the 1/4, you get x to the 1/2. Then you go to the next term. The next term says negative x to the 1/4 divided by x to the 1/4. Anything divided by itself is a 1. You can say this cancels out, but I have to have a number here. So something divided by itself is 1, and I have a negative sign, so we're actually going to get a negative 1 here. So a negative x to the 4th divided by a positive x to the 4th is a negative 1. That's actually my answer there. So what makes this problem hard are the exponents that are fractions. You can multiply the x to the 1/4 back in by adding the exponents, and you should get the original problem. Alright, in example 98, I already see that I have a common group. I have an x squared plus 4 and I have an x squared plus 4. So that x squared plus 4 is actually going to be my GCF. Now to decide on my exponent, I'm going to check to see which exponent is the smallest. So 3/2 is going to be smaller than 7/2. So I'm going to factor out x squared plus 4 to the 3/2. This is going to look really weird, but we're going to do it. Now I'm going to use brackets here because I've already used parentheses. So my GCF is x squared plus 4 to the 3/2, and I'm going to divide that out of my first term. So either in your head or over to the side, you're actually doing, kind of running out of room here, but you're doing x squared plus 4 to the 3/2 divided by x squared plus 4 to the 3/2. So that would be like dividing something by itself. Something by itself. So anything divided by itself is 1. So you get a 1 there. And then you're going to do x squared plus 4 to the 7/2 change this to the 7/2, divided by x squared plus 4 to the 3/2. So these are not going to cancel here because the exponents are different. So you'll bring this 3/2 up because 3/2 is smaller than 7/2. And you'll do 7/2 minus 3/2. So that's going to give us x squared plus 4 to the 4/2. And then the 4/2 will reduce to be a 2. So when you divide x squared plus 4 to the 7/2 by x squared plus 4 to the 3/2, you actually get x squared plus 4 squared. And we'll let you leave your answer just like that. Alright, hope these examples help when you're doing your homework tonight.